So guys, we're starting 13.1. Today we are going to be translating, rotating, and reflecting geometric figures. Now, the translating we're going to go through pretty quickly because we've actually been doing it a lot. And we also looked at reflecting figures a little bit a couple of units ago. So translating and reflecting should be pretty familiar to you. Rotating is going to be the brand new one. But we're not going to be translating and reflecting just lines or points anymore. Now we're going to be looking at entire geometric figures. So let's look, we're going to skip that page. Let's look at problem number 1. And the first part of problem 1 is nice and easy. All it tells us to do is to graph a trapezoid. By plotting the points, A is 3, 9. B is 3, 4, C is 11, 4, and D is 11, 10. So let's do that right now. Now, if you guys notice the scale here, every other line is a multiple of 4, which means all of the little grid lines are 2. So make sure that you are aware of that. So to do 3, 9, we're going to go right, one whole grid line, which is 2, and then 3 is right in the middle. And we're going to go up to 9, which is also right in the middle. So A is going to be right in the middle of a box. B is at the point 3, 4, so we're going to go over 2. 3 is right in the middle, and then 4 is going to be right here, and label that one B. C is 11, 4, so 11 is going to be in between 10 and 12, and then up 4, and that is C. And then D is at 11, 10, so 11 was right here, and 10 is going to be actually on the line right there. And then we're going to connect it. So this is a trapezoid. A trapezoid has 4 sides. The lengths of all 4 sides are not necessarily equal, okay? So this trapezoid has 2 right angles and then kind of a diagonal line. It is actually the same trapezoid as the one we were supposed to cut out, this guy right here. But we're not going to do that. We're just going to plot the points. Okay? So far so good? Okay. So then let's look at what part 2 tells us. Part 2 says, or number 2, says to translate the trapezoid on the coordinate plane and then graph the image and record the vertex coordinates on the plane. Vertex means all of the points that we graph, so point A, B, C, and D. So the first part we're going to do, I'm going to do with you guys, and then you guys are going to do part B on your own. We want to translate the trapezoid 15 units to the left. So any ideas as to how we can do that? Exactly how we did with the angle, so each point individually. So let's do point A first. So guys, really quick, as a reminder, 15 units is an odd number, but all of our lines are even numbers, so you have to make sure that you're counting half of a grid line as a 1. So from A, I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that's A prime. The coordinate of A prime is -12, because that's where we ended up. And if we go up, it's in between 8 and 10, so the y coordinate is going to be 9. Okay, so I filled that in my box already. So the coordinate of A prime is -12, 9. So let's do the same thing with B. We're translating it 15 units left. So each half grid line is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and that's B prime. What are the coordinates of B prime, guys? Negative 12, positive 4. Good. Okay, let's do C prime. Same thing. So we're going to count over 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. C prime. What are the coordinates of C prime? Negative 4, positive 4. That one was lucky. We landed right on a cross. And then D prime, we're going to move D over 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And guys, what are the coordinates of D prime? Negative 4, positive 10. Okay, so let's draw that trapezoid. And what do you guys notice about our coordinates as when we translated the trapezoid 15 units to the left? All of the y values are the same. What changed? The x values. And what did we do with them? If we moved 15 to the left, how did we get our new x values? We subtracted 15. Okay? So here's what I want you guys to do on your own. I'll give you like 2 minutes to do it. I want you to now do part B. Translate the trapezoid A, B, C, D. So you're not translating this orange one, you're translating the pink one again. So the original trapezoid, you are translating it 12 units down to form A double prime, B double prime, C double prime, D double prime. So you're taking the original A, B, C, D trapezoid, so this one right here, and you're translating it down 12 units. Okay, so I want you guys to do that in your groups. Translate it down, and then give me the coordinates on the table. Okay, so when you translated your trapezoid down, A double prime, B double prime, C double prime, D double prime should have ended up right here, yes? Everybody check yours, make sure that it looks like this. Okay, so it should have ended up right here. So then let's look and see what the coordinates are. What did you guys get for the coordinates of A double prime? 3, negative 3. What about B double prime? 3, negative 8. C double prime? 11, negative 8. And D double prime? 11, negative 2. Okay, so how did translating the trapezoid down affect the coordinates? Just the y coordinates, and what did we do? We subtracted what? 12 from each one. Okay, so when we're translating left and right, we either add or subtract from the x coordinates. When we're translating up and down, we add or subtract from the y coordinates. Okay, so that should be a little bit of review for us, right? Okay, so let's try that now without actually having to graph. So flip this over. So let's look at number 3. Let's consider translations without graphing. The vertices of parallelogram D, E, F, G, R. D is negative 9, 7. E is negative 12, 2. F is negative 3, 2. And G is 0, 7. I just underlined those so I don't lose them because we're going to use them for 2 problems. So here is problem part A that we're going to do. Determine the vertex coordinates of image D prime, E prime, F prime, G prime if the parallelogram is translated 14 units down. So underline that part, 14 units down. So guys, I'll do the first one with you. So D prime. If we are translating 14 units down, is that affecting the x-coordinate or the y-coordinate? The y-coordinate, and since we're going down 14 units, what am I going to be doing to the y-coordinate? Subtracting 14. So the original D is negative 9, 7. So negative 9 is going to stay the same. 7 minus 14 gives me what? Negative 7. I want you guys to do E prime, F prime, and G prime. Okay, guys, let's check our answers. So for part A, we decided that the x-coordinates stay the same, and the y-coordinates we're going to subtract 14. So what did you get for E prime? Negative 12, negative 12. Good. Okay, what about F prime? Negative 3, negative 12, and G prime? 0, negative 7. Good. Okay, any questions, comments, or concerns about that one? Okay, so the y-coordinate changed on that one. So now let's look at part C. So we were skipping B. Let's look at C. C wanted us to take the original parallelogram again, so the original coordinates that you underlined, not the ones that we did in part A. And it wanted us to translate those 8 units to the right. Now, if I'm translating to the right, does that affect the x-coordinate or the y-coordinate? The x. And since I'm going to the right, what am I going to end up doing? Adding 8. So what would we do with D double prime if we had negative 9, 7, and we add 8? Negative 1, positive 7. What about E double prime? Negative 4, positive 2. F double prime? 5, positive 2. And G double prime? 8, 7. Good. Okay? So translating up and right, you add. Left and down, you subtract. Okay? So that's that. So, problem 2, we're going to look at rotating. So, another transformation that exists in geometry is a rotation. A rotation is a rigid motion that turns a figure about a fixed point called the point of rotation. Let's highlight that. So, a rotation is a rigid motion that turns a figure about a fixed point called the point of rotation. So, we are rotating it. Okay? The figure is rotated in a given direction for a given angle, called the angle of rotation. The angle of rotation is the measure of the amount the figure is rotated about the point of rotation. So let's highlight that part. The angle of rotation is the measure of the amount the figure is rotated about the point of rotation. So how many degrees did I rotate that figure? The direction of a rotation can either be clockwise or counterclockwise. So let's talk about that for a second. Here's what I always do to help me remember. Clockwise or counterclockwise, that's referring to the clock. So if we drew a clock, we have 12, 3, 6, and 9, and then you have your little hands. Which way does a clock turn when it's telling time? To the right. So if it's going this way, that is called clockwise. So rotating to the right is called rotating clockwise. So which direction do you think counterclockwise is? The opposite way. So going to the left is called counterclockwise. Okay, so clockwise means that it's going the direction that a clock rotates, so to the right, going this way. Counterclockwise means it's going the other direction, so rotating to the left. Okay, so that's clockwise and counterclockwise. So, rotating. So what they did was we're going to rotate a point about the origin, and we will rotate the point 90 degrees, 180 degrees, and 270 degrees. So remember, 90 degrees is like a right angle, 180 degrees is 2 right angles, so a straight line, and 270 is 3 right angles. So we're going to rotate this point that they give us 90 degrees counterclockwise, so that's going to the left about the origin. So here's what the steps that they tell us to do. The first step is to plot a point anywhere in the first quadrant, not at the origin. So they gave us the point 2, 1. So point A is the one that we're going to do. So the point A at 2, 1, we're going to rotate that 90 degrees about counterclockwise about the origin. So the part where it says 90 degrees, that's telling you the angle of rotation. counterclockwise tells you the direction. And when it says about the origin, that means that the origin 0, 0 is the point of rotation. So the origin is like if you were to take your finger and put your finger at the origin, that point isn't moving and everything else is moving. Does that make sense? So the origin is the part that's not moving and everything is rotating around that spot. Okay? So then what they did was they drew what they called a hook from point A to the origin. So they went from point A down, because we can only use straight lines, and then to the left to get to the origin. And then it's as if they put their finger on the point of the origin and rotated that hook 90 degrees. So where did A prime end up being?
So wherever the lines are, that's what you have to do.
Correct. So since we're rotating it 90 degrees, I take that long line and I flip it up the same amount. And this part that's attached to it is now going out to the other direction. So that's why they drew the arrow. It's kind of like they're taking this hook right here, and then the arrow is rotating it 90 degrees to the left. So you just have to visualize it kind of moving up, rotating around. For our purposes, we're going to do 90 degrees, and then we're going to do 180 degrees. So 180 degrees would be rotating it this direction 90 degrees, and then another 90 degrees. So that's all we're going to be doing today. Okay? Does that make sense now? That you can like visualize it? So what do you notice about the original point A and our new point A prime? Yeah, what do you notice about the numbers? They're flipped. So the original X was 2 and the new Y is 2. The original Y was 1 and the new X is -1. So the coordinates flipped, and then what happened to the X? It turned negative. Okay, so what I want you guys to do, if you flip your page over, that's the question that number 1 asks. What do you notice about the coordinates of point A and A prime? Will you write that in your own words? Some way, write it in your own words. You can talk about it with the people in your group to write that the X and the Y flipped and the new X also became negative, or the opposite. Okay? And then here's how I wrote it. The X and the Y coordinates switched places, and the new X coordinate became the opposite of what it was. Okay, does that make sense? Okay, yours should sound something like that. So now let's look at part 2. So now, and it's really nice because they give us the graph down below, so just refer to the graph down below. Predict what the coordinates of A double prime will be if you rotate A prime 90 degrees counterclockwise about the origin. So A prime is the new one that we did down here. The coordinates are -1, +2. Now let's predict what will happen if we rotate that one 90 degrees counterclockwise. So what do you guys think will happen? Talk about it in your groups. Predict what the coordinates will be. Does anybody want to share what they got? Okay, so the coordinates that we are rotating are at -1, +2. So if we were to rotate that coordinate 90 degrees counterclockwise, what would we get? I'm hearing two different things. -2, -1, or... So what did we decide happened when we rotate 90 degrees? We flip the X and the Y, so -1 now becomes our Y, and then what also happens to the X? It becomes the opposite. So what's the opposite of 2? So we predict that it's going to end up being -2, -1. Does everybody agree with that? So let's see. So let's draw our hook. So down below they regraphed it all for us, so let's actually do it. So we need to draw a hook that gets us to the origin, which is 0, 0. So let's go 2 units to the right, and then down. Or 1 unit to the right and 2 units down, because it's by halves. And then we're rotating, remember, 90 degrees counterclockwise, so that means we're rotating to the left. So that hook right here is rotating 90 degrees to the left. So the height of 2 is now going to go out this way, and that 1 is going to be going down. So where did my point end up? -2, -1. So were we correct? Good. Okay, so you have to just imagine that hook kind of going down. So now here's what I want you guys to do. Look at my original, we're going to skip part A, look at part B. It wants us to compare the original A and now A double prime. So here's the original A at 2, 1, and A double prime ended up being at -2, -1. What do you notice about the coordinates there? They're just the opposite, right? It went from 2 to -2 and 1 to -1. So will you guys write that in part B? I wrote that the coordinates are opposites after rotating 180 degrees counterclockwise. Yes? Okay, explain. Here is all of that information that we just learned in a nice chart for you. So, if we are rotating counterclockwise, my original point is XY, so there's actually going to be numbers there. If we rotate 90 degrees counterclockwise, the X and the Y switch places, and that new X becomes negative. So it gives us X and Y in terms of the original point. If we rotate 180 degrees counterclockwise, they stay in the same spot, but we take the opposite of each one. And the reason that that happens because we did 2 90-degree rotations to get to 180 degrees. So what I want you guys to do is just off to the left, will you, next to that table, write rotating counterclockwise? So just label the table. Because this is actually going to be a really good helper for you on the homework and in studying for the test. Okay, so just label your table. It's going to be like that every time.
Every time we'll start off with like a...
And it will give you an original point, and I'll either ask you to rotate 90 degrees counterclockwise or 180 degrees counterclockwise.
So it will always be two positive points in the original point?
Not always, no. So the negative, so the question was, will the original point always be 2 positive points? The answer, for our purposes, right now I think yes, but not always. But it doesn't really matter because when you take the negative of a negative, it becomes positive. So the negative just means opposite. Okay? So here's what I want you guys to do with your groups. I want you to look at number 4 and do number 4 for me really quick. So number 4 is just going to have you graphing a point. Okay, guys, this part should have been easy. All I wanted you to do was label the point 5, 7, and label it Q. Yes? Okay, so I just want you to double check to make sure we all are starting at the same point. So what I'm going to have you guys do to see if you all got this, flip the page and with your groups, do all of number 5. So parts A, B, C, and D. It's going to have you rotating, and then it's going to have you writing out the coordinates of the new point after rotating. So using Q with your groups, and I want you guys to be working together, so I should hear some talking. You're going to be completing all of number 5, which is rotating Q 90 degrees counterclockwise, and then 180 degrees counterclockwise. Okay, so on the other side of the page, the question, part A wanted us to rotate Q 90 degrees counterclockwise, and they wanted us to call that Q prime. So that means we're taking Q, and we need to make our hook first. So some of you went left and then down. Some of you went down and then left. It doesn't really matter. But you take that hook, and then we are rotating it to the left 90 degrees. So that means that the height is now going to become how many spaces over I go, which is 7. So we're going to go to the -7. And then the width of that hook is going to become my height, so that is 5, right? So we're going to go up to 5. So Q prime should have ended up at -7, +5. So that would put us this way. Okay? So then on part B, you should write Q prime is -7, +5.
Positive.
Oh, positive, thank you. +5. I said +5, I wrote -5. -7, +5. Okay, how many got that right? Thumbs up. Awesome. Okay, so then they wanted us to take Q again. So this time they said take Q, our original, and rotate it 180 degrees around the origin counterclockwise. So I'm going to take this original hook that I made, and I've rotated it 90 degrees already, and then I'm going to rotate it another 90 degrees to end up in quadrant 3. So that means my width actually stays the same, and the height also stays the same. So where did Q double prime end up? -5, -7. Good. So then for part B, Q double prime is -5, -7. Okay? That's all I wanted you to write. A couple of you were asking me about the coordinates and that were given in the chart. Remember, the chart is giving us everything in terms of general notation. So x comma y means that that's my original x comma y. Anytime we switch the numbers or whatever, it still stays in the form x comma y. So what I was doing with some of you as I was walking around was I was giving you a specific numerical example. So let's say in your chart that the xy is 2, 3. If I rotate it 90 degrees counterclockwise, then what does it become? -3, +2. And if I rotate it 180 degrees, it becomes -2, -3. So sometimes just putting numbers in there kind of helps too, okay? So that's just going back and adding numbers to our chart. Okay? And now let's talk about rotating a trapezoid. Now don't read all of this stuff because it was taking the one that we cut out and rotating it around, and we're not going to do that. But we are going to graph the trapezoid. So what we're going to do is in part 6, we're going to graph the trapezoid by plotting these 4 points. And then it's going to show us how it's rotated. So can I have you guys plot those 4 points for me right now? Kind of the idea with this one. I'm going to use the trapezoid that I cut out just to show you, but so don't look at the picture down here, just look it up here. So here, when we are rotating actual figures, here's our original trapezoid. So my original trapezoid fits right in there. And when we're rotating it about the origin, we're putting like our pencil right there on the trapezoid, and it is rotating 90 degrees about the origin. So it would end up right there. If I was rotating 180 degrees, you can't see, I would do it again, and it would end up right there. Okay, so that's kind of what we're doing. It's exactly like what we just did when we were translating the trapezoid. So we would do rotate each individual point 90 degrees, and that will give us the coordinates of the new trapezoid. So the rule is actually the same as it was for what we just did with an individual point. So that's what we're going to do right now on the next page. So turn the chart, or turn to the chart. And what we're going to do is we're going to do parts A and B, but we're going to find the coordinates, and then we're going to plot those coordinates, okay? So part A wants us to rotate the trapezoid, A, B, C, D, 90 degrees counterclockwise about the origin to form A prime, B prime, C prime, D prime. So if I am rotating each individual point 90 degrees about the origin, C prime, D prime. Let's figure out what each of those individual coordinates would be. So if the original A coordinate is negative 12, positive 9, what would be the A prime coordinate? We're rotating 90 degrees.
Could be, negative 12, or negative.
Negative 9, negative 12, because remember it stays the same, just the new x changes. So what would be B prime?
Negative 4,
Negative 4, negative 12. What about C prime? Negative 4, negative 4. And D prime? Negative 10, negative 4. So what I want you guys to do right now is graph that new trapezoid. So turn back to the graph on the front and then graph those coordinates. On the same graph. So it won't be on top of it, it should be in the next quadrant. So here's what your new trapezoid should have looked like. Let's check it with the actual one that I cut out to make sure that it does end up in the right spot. So remember, here's my original. I'm just going to place it right inside. I'm going to put my pencil on the origin, and I'm going to rotate it 90 degrees. Did we end up in the right spot?
Yeah.
Yeah. Okay? So that's kind of how this is all working. All right? So typically what you will end up doing is you will find the coordinates of the rotation, and then you will graph the new coordinates. So you won't have to try and visualize it every single time. You'll find the coordinates first and then graph. So will you guys do for me part B? So part B wants us to take the original trapezoid, so the original one, and rotate it 180 degrees counterclockwise. So will you find me the new coordinates? And then graph that on the graph as well.
So would it be?
So the first one would be, remember, if we're rotating 180 degrees, we just take the opposite. So the first one would be positive 12, negative 9, right? Okay? So let's check our coordinates, guys. So I did A double prime for you. What did you get for B double prime? I hear 12 and negative 4. What about C double prime? 4, negative 4. And D double prime? 4, negative 10. So when you graphed those points, they should have ended up right here. Okay, make sure you have that and make sure that you labeled it. If we are to check that point using the trapezoid that I cut out, rotating it once is 90 degrees, rotating it twice is 180, and we ended up in the right spot. Okay, so your trapezoid, when you graph those points, should have ended up in quadrant 4 this time. Okay, not too bad. Let's do it one more time without actually having to graph. And you guys are going to do this one on your own with your group members to help you. So turn to the next page, and now we're going to rotate without graphing. So underline the original point. So I'm giving you a parallelogram, D, E, F, G. D is at negative 9, 7. E is negative 12, 2. F is negative 3, 2. And G is 0, 7. Part A, I want you to determine the vertex of the coordinate, D, E, F, G prime, if the parallelogram is rotated 90 degrees counterclockwise about the origin. So I'm going to start this one with you. If we are rotating it 90 degrees, what would be the coordinate of D prime? Negative 7, negative 9. So you guys are going to finish that for E prime, F prime, and G prime. F prime and G prime. And then you guys are also going to do part C for me. You are going to rotate the parallelogram D, E, F, G, so the original, 180 degrees counterclockwise. So guys, really quick, if I was rotating the original parallelogram 180 degrees, point D, which is negative 9, positive 7, would turn into what? Positive 9, negative 7, right? Okay, so it's always going back to the original. So do parts A and part C for me with your group members. Okay, guys, let's check our answers. So, E prime, what did you guys get for E prime in part A? Positive 2, negative 12?
No, negative.
Negative 2, negative 12. What about F prime? Negative 2, negative 3. What about G prime? Negative 7, 0. Excellent. Okay, let's look at C. So part C, we were taking our original parallelogram, so you're going back to those original coordinates, and we were rotating 180 degrees. So that means that we are just taking the opposite of each coordinate. So we got D double prime as 9, negative 7. What about E double prime? 12, negative 2. F double prime? 3, negative 2. G double prime? 0, negative 7. Good. Please notice that before each coordinate, I put what the name of the point is. So that's standard practice so that you're not just listing a bunch of coordinates. I need to know that D double prime is this one. So please don't just list the coordinates. Make sure that you're putting the labels in front of them. Okay? Everybody good so far? Okay, so we did translating, which is just moving it around. We did rotating, which is kind of turning it around like a clock. The last thing we're going to talk about is reflecting, and we did kind of talk about this already, so we should be able to go through it pretty quickly. So let's turn the page. So last part, reflecting. There is a third transformation that can move geometric figures within the coordinate plane. Figures that are mirror images of each other are called reflections. That makes sense, right? A reflection is a rigid motion that reflects or flips a figure over a given line called the line of reflection. A line of reflection is a line over which a figure is reflected so that corresponding points are the same distance from the line. Do you guys remember in preschool when you learned about symmetry and you like painted one side of the butterfly and then you folded it in half and then opened it up? That's kind of like your line of reflection, is where you fold it. And then the reflected image is what shows up on the other side, okay? So those are your definitions. What I want you guys to do is have one person in your group, different than the person last time, read the notebook page. So it has step 1, 2, and 3 on the other side. Okay, so read the notebook page on how to reflect, and it goes on to the other side. Okay, so let's talk about this one. So reflect about the y-axis is what we're doing. The y-axis is the one that goes up and down. The first thing we're going to do is plot a point anywhere in the first quadrant, not at the origin. So they picked the point 2, 1. And what it said in our definition is that the corresponding points are the same distance from the line of reflection. So first thing we have to do is we need to figure out how far this point is from our y-axis. So we counted the number of units from point A to the y-axis, which was 2 units. So that's what they did there. Okay? So it's 2 units from the y-axis. The y-axis is our line of reflection. So if I was to fold the paper in half on the y-axis, my second point, the reflected point, would be 2 units away from the y-axis. So we counted 2 units in the opposite direction from the y-axis and plotted that point. So the new point ended up being at -2, +1. So what do you guys notice about the coordinates? The original coordinate was +2, +1, and the new coordinate was -2, +1. What do you guys notice? The x is opposite. What about the y? The y stay the same. Will you write that on number 1? So the x coordinate is opposite. And the y coordinate stays the same. Okay. And that's when we reflected over the y-axis. So I'm going to read you the next question. I want you to think about it, and then you're going to share with your neighbor what you think will happen. predict the coordinates of A double prime if A, the original A, is reflected over the x-axis. Okay, so think about what would happen if we reflect that point over the x-axis. Tatiana thinks that the x-coordinate is going to stay the same, and the y-coordinate is going to become the opposite. So what would the A double prime end up being if my original point is 2, 1? 2, negative 1. So let's write that in words also. So to reflect over the x-axis, the x-coordinate will stay the same. And the y-coordinate will be opposite.
So do you always start from the original point?
Yeah, you're always going to start from the original point. And it will tell you in the problem too. It actually said in the problem, what are the coordinates of A double prime if the point A? So the point A was our original point. So you have to make sure that you're reading the question as to which point you're reflecting. Okay? So then part 3, now that we predicted it, will you guys actually plot that point in number 3? Okay, so number 3 wants you to take that A double prime and actually reflect it over the x-axis. So in terms of the y value, it's 1 point away from the x-axis. So to get the next coordinate, it's going to be 1 point away. So A double prime ended up being at positive 2, negative 1, which is what we predicted. So just graph that right there. Okay, guys, so they give us a chart here. Will you title the chart Reflections to the left of it? So reflection. And then I really liked Jordan highlighted her chart, so I'm going to highlight mine too, because it is super important. Okay, so they give us all that information in a chart to kind of help us out. So if my original point is xy, and I reflect over the x-axis, my x stays the same and my y becomes opposite. If I reflect my original point over the y-axis, my y stays the same and my x becomes opposite. So whichever axis you're reflecting, that coordinate gets to stay the same. The other coordinate takes the opposite. So let's actually put some numbers in there to kind of help us out. So I'm giving you the original point, 2, 3. If I'm reflecting that over the x-axis, what would my new coordinate be? 2, negative 3. If I'm reflecting that point over the y-axis, it would become negative 2, positive 3. So sometimes just having a number example in there kind of helps. So those are reflections. So I'm going to have you guys do some on your own really quick just to kind of test, and then we're going to do it with the trapezoid again, and then we're done. Okay, so flip the page. So part 5 wants us to graph the point J at 5, 7. So 5, 7 is right here. Label it J. So that's part 5. Do numbers 6, 7, 8, and 9 for me with your group. So number 6, you're going to reflect J over the y-axis. And then tell me what the coordinates are. Number 8, you're going to reflect J over the x-axis and tell me what the coordinates are. Okay, so do 6 through 9 with your group for me. Okay, so the next thing they wanted us to do was they wanted us to reflect J over the y-axis. So the y-axis is my point of reflection. So that means that J is 1, 2, 3, 4, 5 boxes away from the y-axis. So I need to count 5 coordinates over in the opposite direction. So 1, 2, 3, 4, 5, and we're going to call that J double prime, or J prime, sorry. So what were the coordinates of J prime?
-5.
-5, +7. That should be easy, right? Okay. The second one they wanted us to do was reflect J, so the same one, the original J, over the x-axis. So I need to count how many spaces it is from the x-axis. From the coordinate, we know it's 7 spaces away. So I'm going to count 7 spaces in the opposite direction. So J double prime should have ended up over there. And what were the coordinates of J double prime? 5, -7. Okay, remember, make sure that you are labeling the coordinates. Okay? Okay, so let's graph our original trapezoid ABCD. It's at 3, 9, 3, 4, 11, 4, and 11, 10. So will you guys graph the original trapezoid for me? So at 3, 9, 3, 4, that's A, B, C is 11, 4, and D is 11, 10. It's the same size as that teeny trapezoid that we've been working with.
I don't like how it's like
So that's our trapezoid, and then we're going to be using this to graph as we reflect the trapezoid, so just kind of leave it right now. This picture right here sort of gives you an idea of what's going on. So if we take our trapezoid and we are reflecting it about the y-axis, that means that it is flipping about the y-axis. So it's like the butterfly. You fold the paper in half, and then the symmetrical version comes out on the other side. If I take the one that I cut out, it's like I take my trapezoid, and then I just flip it over, and the new trapezoid is over there. So that's kind of what's going on. Just like we've been doing, you can do this by reflecting each individual vertex, and then that's going to give you the coordinates of your new trapezoid. So let's flip over your page, and let's find the new coordinates in the chart. So we're going to do part A first. And part A, now I want you guys to read the instructions. Part A says that we are reflecting the trapezoid over which axis? The x-axis. So are my x-coordinates changing or staying the same? Staying the same. So A prime, B prime, C prime, and D prime. If I'm reflecting over the x-axis, that means I'm flipping it upside down. So my x-coordinate gets to stay the same, and what happens to the y? It's the opposite. So then B prime is going to be +3, -4. What's C prime going to be? 11, -4. And D prime is going to be 11, -10. So if we were to graph that on the graph, we're going to graph each of those points individually. So A prime is +3, -9, so right here. B prime is +3, -4. C prime is +11, -4, so right here. And D prime is +11, -10, so right here. So we just took our trapezoid and we flipped it upside down. Okay? So I want you guys to do part B of that. So you are going to be taking your original trapezoid, this guy right here, the pink one, and we are going to reflect it over the y-axis. Okay? So do the exact same thing for the other chart and then graph it. Okay guys, let's check this really quick. So if we are reflecting then our original trapezoid, so the far left column, over the y-axis, what would be the coordinate of A double prime? -3, +9. What about B double prime? -3, +4. C double prime? -11, 4. And D? -11, 10. So when you graph that, it should end up in quadrant 2, somewhere here. That should be A double prime. D double prime would be, it's 11, so here. And then B double prime and C double prime. So everything should end up there. Okay? How do you guys feel about all of it? Okay, last thing we're going to do, just to make sure. I know. Number 13, we're going to do parts A and C again. So C is on the other page. I'm giving you parallelogram. Here are the vertices of the parallelogram. Part A, I want you to give me the vertices if we are reflected over the x-axis. Part C is on the other page, and that is the vertices if we are reflected over the y-axis. So do parts A and C for me. You can get help from your group. Okay, so for part A, the instructions said we were reflecting over the x-axis. So that means our x-coordinates stay the same, and our y-coordinates are the opposite. So D prime should have been -9, -7. E prime should be -12, -2. F prime should be -3, -2. And G prime should be 0, -7. Okay? So when we're reflecting over the x-axis, we're flipping it upside down, so my x's get to stay the same, but my y's are the opposite. Part C, we were taking our original parallelogram, so the original coordinates that they gave, but we were reflecting over the y-axis. So my y-coordinates stay the same, and my x-coordinates are the opposite. So my D double prime should have been 9, 7. E double prime should have been 12, 2. F double prime should be 3, 2. And G double prime, the opposite of 0 is 0, so it stays as 0, 7. Okay.